Hi everyone, we are going to learn about normal distribution today, and this is the last topic of statistics in IB Math AASL. Let's start. Now we know that numbers can be distributed or spread out in different ways. It can be spread out more to the left, something like this, and we call this kind of graph skewed to the left. It's because if you look at this graph, you can see that there is a tail on the left hand side of this graph. That's why we call this skewed to the left. Now numbers can also be spread out more to the right, something like this. And if you look at this graph, you can see that there's a tail on the right hand side of the graph. So we call this skewed to the right. Skewed to the right. Now, sometimes if you plot numbers, it can also look like this. It's a mixed one, and it's neither skewed to the left or to the right. However, sometimes you will come across graphs that look like this. It is a bell-shaped graph, and this is an example of normal distribution. So this is our bell-shaped curve, and we are going to study this today. It means that most of the numbers are clustered around the mean. If you look at this graph, you can see that most of the numbers has this number. It could be anything like 150 or 50. Now, it is a symmetrical curve where the right and left hand sides are almost equal. So this is our normal distribution. This is a graph of normal distribution. Now, a very common example would be height. Most of the people in a specific population are of average height. Only few people would be very tall or very short, but most of the people would have of the same age would have something around this number. Another example would be the birth weight of newborns. The majority of newborns have normal birth weight, something like this. It will be here maybe 2.5 to 3 kilograms. Only a few percentage of newborns have a weight that's higher than this or lower than this. Now let's discuss the properties of normal distribution. Number 1, the mean, median, and mode are always going to be equal for normal distribution. So if you calculate, if you find the mean, median, and mode of some numbers, and if you see that it's all the same, that means that's your example of normal distribution. Number 2, this graph is always a bell-shaped curve, and it's always going to be symmetrical around the mean. This is the second property. Number 3, we use two important parameters to describe this normal distribution. The first one is mean, and we represent this by using this letter. And the second one is standard deviation, and we represent that by using this letter. So these three things are very important to understand normal distribution. Now let's discuss few examples with numbers. Let's say the mean score of SAT is maybe 1150, and it has a standard deviation of 150, for example. Now we always represent this information like this. We always write the mean first and then the variance. So in this case, we can write it like this, 1150, because that's the mean, and standard deviation in 150, so you put a square to represent the variance, but the standard deviation is the square root of variance, so it's just going to be 150. So if you ask me to draw this graph, I'm going to draw something like this. We know that this is normal distribution. That means most of the students will have a score of 1150. Now, if I ask you to draw one standard deviation of the mean, you're going to plus minus 150 from it. So if you add 150 to 1150, you're going to get 1300. And if you subtract 150 from this, you're going to get 1000. This is one standard deviation of the mean. So we call this the first one standard deviation of the mean. And if you calculate the percentage of this, it's always going to be 68% all the time. Then if I ask you to draw the second standard deviation of the mean, you are going to plus minus 2 times the standard deviation. So let me extend this graph a little bit. So let's say I add 300 to this. I'm going to get 1450, and if I subtract 300 from the mean from the average, then it's going to be 850. So this is going to be my second standard deviation of the mean. Second standard deviation of the mean. And if you calculate the area under it, the percentage, it's always going to be 95%. So this part of the graph is always going to be 95%. If I ask you to draw the third standard deviation of the mean, you are just going to plus minus 3 times the standard deviation. So in that case, this would be, sorry, I'm running out of space. This is going to be 1600, and if you subtract 150 from this, it's going to be 700. Now this is the third standard deviation. This is the third standard deviation, and if you calculate the probability, the area under it, it's always going to be 99.7%. Please remember this is very important, and it's always going to be like this: 68%, 95%, and then 99.7%. Now in any normal distribution, no matter what the values of your mean or standard deviation are, the total area under this curve is always equal to 1. So the total area under this, it's always going to be 1. That means 100%. Therefore, partial areas under the curve represent your probability. So if I ask you to find the probability of a student scoring between something around this range, greater than 1000 and less than 1300, you can see that this is my first standard deviation of the mean, right? It's this one. So that means, like I told you before, it's 68%. That means the probability is going to be 0.68. So there is a 0.68 68% chance that a student is going to score more than 1000 and less than 1300. If I ask you to find the probability a student scoring greater than 850 and less than 1450, it's going to be, you know that it's 95%. That means the probability is 0.95. If I ask you to find the probability of a student scoring greater than 700 and less than 1600, you can see from the graph that this is the third standard deviation. It's going to be, we know that it's 99.7%. That means the probability is going to be 0.997. Okay, so that will be all for now. See you next time. Thank you for watching this video.